Hey everyone, welcome back to the channel. If you're new here, I'm Sanjai Kumar, and I help database professionals optimize Oracle performance. Today, I'm going to show you a powerful hack that can transform slow-crawling queries into lightning-fast performers. I'm talking about dynamic sampling. And trust me, this isn't just theory. I've used this in production environments to turn 45-minute queries into 12-second queries. But here's the thing. Dynamic sampling isn't a magic bullet. There are advantages and disadvantages you need to know before implementing it in your environment. So, let's dive in. Alright, let's talk about the problem first. Imagine this scenario, and I bet many of you have faced this. You have a table with 10 million rows. Your query has a perfect index, but when you run it, it's doing a full table scan. Why? The answer? Stale statistics. The Oracle optimizer is making decisions based on old information. Maybe your statistics say the table has only 100,000 rows. Maybe they were gathered weeks ago, and your data has completely changed. The optimizer thinks, hey, 100K rows, a full table scan is cheaper than an index lookup. And boom, you're scanning 10 million rows unnecessarily. This happens all the time after bulk data loads, large delete operations, ETL processes, data warehouse refreshes, anytime data changes significantly between statistics gathering. And here's what makes it worse. You might not even know it's happening until users start complaining about slow performance. Example of bad execution plan. Let's see the bad execution plan first. Alter session. Set optimizer underscore dynamic underscore sampling equal to 0. Sample query that will suffer. Explain plan for select. O.order ID, O.customer ID, O.order total, O.order date. From orders O, where O.order date between sysdate minus 30 and sysdate, and O.status equal to pending, and O.region equal to west. Display the plan. Select star from table dbms underscore xplan dot display format equal to all. Bad execution plan output. Table access full, it's scanning the entire table. Estimated rows 50,000, but in reality only 1,200 rows match. Cost 85,000, extremely expensive. Time, 17 minutes, users are waiting, and waiting. Note says statistics are stale, red flag. The optimizer thinks there are 50,000 matching rows based on old statistics, so it says, might as well scan the whole table. But there are actually only 1,200 rows, and we have a perfect index. So what's the solution? Dynamic sampling. Let me explain what this does. Instead of trusting old statistics, dynamic sampling tells Oracle, hey, I don't trust these stats. Sample this table right now during query optimization and make a decision based on current data. It's like the difference between using a map from 5 years ago versus pulling up Google Maps with live traffic. You want current information to make the best decision. Let me show you how to check your current setting. Check your current dynamic sampling level. Select name, value from $v parameter, where name equal to optimizer underscore dynamic underscore sampling. Show parameter optimizer underscore dynamic underscore sampling. By default, most databases have this set to 2 or lower, which is pretty conservative. Now here's how you enable it. You have 3 options. Option 1, session level, my recommended starting point. Alter session. Set optimizer underscore dynamic underscore sampling equal to 6. Option 2, query specific hint for targeted optimization. Select hint. Starting dynamic underscore sampling orders 6. Hint ending customer ID order total from orders, where order date size date minus 30. Option 3, system level, use with caution. Alter system. Set optimizer underscore dynamic underscore sampling equal to 6, scope equal to both. Now, notice that number 6? That's the sampling level, and it ranges from 0 to 11. We'll talk about what level to use in a minute. Demonstration. Let me show you a real example. Watch this. First, let's run a query without dynamic sampling. Alter session. Set optimizer _dynamic _sampling. 0. Explain plan for select customer ID. Count. Sum order total from orders. Where order date add months, sysdate -1. And region equal to West, group by customer ID. Select star from table, dbms _xplan.display format equal to basic plus rows plus cost. See this? Full table scan, scanning 10 million rows. Cost, 85,000, very expensive. Estimated rows, 50,000, but actual is only 2,400. Time, 17 minutes, unacceptable. Now let's enable dynamic sampling and run the same query. Alter session, set optimizer _dynamic _sampling equal to 6. Explain plan for select customer ID, count star, sum order total, from orders where order date add months, sysdate -1, and region equal to West, group by customer ID. Select star from table, dbms _xplan.display format equal to basic plus rows plus cost. Now look at this transformation. Index range scan, using the perfect index. Cost, 450, down from 85,000, 99.5% reduction. Estimated rows, 2,400, much more accurate. Time, 6 seconds, down from 17 minutes, 170x faster. Note says, dynamic sampling performed. It sampled 2,048 rows to get accurate stats. All right, let me break down these numbers for you because they're absolutely mind-blowing. First, look at the operation. Without dynamic sampling, we're doing a table access full. That means we're scanning the entire table, all 10 million rows. With dynamic sampling, index range scan. We're going directly to the exact rows we need using the index. That's a fundamentally better execution plan. Now check out the cost. Without dynamic sampling, 85,000. With dynamic sampling, 450. Do the math, that's a 99.5% reduction in cost. The optimizer went from thinking this query is extremely expensive to realizing it's actually quite cheap. Look at the estimated rows. This is where it gets really interesting. Without dynamic sampling, the optimizer estimated 50,000 rows, but that's completely wrong. The actual number is only 2,400 rows. With dynamic sampling enabled, the optimizer sampled the table and correctly estimated 2,400 rows. That's accurate. And when the optimizer has accurate information, it makes the right decision. Execution time. This is what your users care about. Without dynamic sampling, 17 minutes. Your users are sitting there waiting, checking their email, getting coffee, wondering if the query is even running. With dynamic sampling, 6 seconds. That's 170 times faster. From, I have time to grab lunch to, wow, that was instant. And finally, rows scanned. Without dynamic sampling, we're scanning 10 million rows, the entire table. With dynamic sampling, we're only scanning 2,400 rows, the exact rows we need. That's 99.98% less I/O. Think about what that means for your buffer cache, your disk subsystem, your shared pool. Everything is more efficient. That's the power of dynamic sampling, folks. One configuration change, and you transform a terrible execution plan into an optimal one. But before you rush to implement this everywhere, let's talk about the advantages and disadvantages. Advantages. Advantage number 1, accurate execution plans. This is the big one. You get execution plans based on current data, not outdated statistics. The optimizer can finally see what's really happening in your tables. Advantage number 2, perfect for volatile data. If you have tables that change rapidly, staging tables, ETL tables, data warehouse fact tables, dynamic sampling is a lifesaver. You don't have to constantly regather statistics. Advantage. 3. Immediate performance gains. No waiting for statistics jobs. No scheduling maintenance windows. Enable it, and your queries immediately benefit from better optimization decisions. Advantage number 4, handles data skew. When you have significant data skew, like 90% of your data has one value, dynamic sampling can detect this and adjust the plan accordingly. Advantage number 5, great for ad hoc queries. For data analysts running one-off queries, dynamic sampling ensures they get good plans even on tables they've never queried before. Let me show you how to identify which tables need this. Find tables with stale statistics. Select owner, table name, num rows, last analyzed, round, sysdate minus last analyzed, 2. As days, since analyzed, stale stats from, dba_tab_statistics, where owner equal to your schema, and last analyzed is less than sysdate minus 7, or stale stats equal to yes. Order by days. Since analyzed desk. Look at this output. These are your problem tables, the ones crying out for dynamic sampling. See the first one? Orders staging. Statistics haven't been updated in almost 40 days, and Oracle has marked it as stale. It thinks there are 8.4 million rows, but I guarantee that number is way off by now. Daily sales fact. This is supposed to be updated daily, but the stats are 24 days old, and it's a massive table, 15 million rows. Every query against this table is making decisions based on month-old information. And check out order line items, 45 million rows. Stats are 13 days old, marked as stale. This is exactly the kind of table where dynamic sampling will save you. These are your candidates for dynamic sampling. Any table here with more than 7 days since statistics were gathered, or the stale stats flag set to yes. These tables need either dynamic sampling enabled right now, or you need to immediately gather fresh statistics on them. Preferably both. Gather stats and enable dynamic sampling as a safety net until you fix your statistics gathering schedule. Disadvantages. Now, let's talk about the disadvantages. And this is critical to understand. Disadvantage number 1. Increased parse time. This is the big one. Dynamic sampling happens during the parse phase. Oracle has to actually sample your table before executing the query. For level 6 sampling, you might add 100-500 milliseconds to your parse time. For level 10 or 11, could be several seconds. Here's the key question. Are you willing to wait an extra half second during parsing to save 10 minutes during execution? Usually, yes, but not always. Disadvantage number 2. Cursor sharing issues. Every time statistics change significantly, Oracle might generate a new child cursor. This can lead to cursor proliferation and increased library cache memory usage. In high concurrency OLTP systems, this can become a problem. Disadvantage number 3. CPU overhead. Sampling tables consume CPU. If you have hundreds of concurrent queries all doing dynamic sampling, that CPU adds up fast. Disadvantage number 4. Not suitable for OLTP. In high-speed transactional systems where you're executing the same query thousands of times per second, that extra parse time multiplies. For OLTP, keep statistics fresh. Use dynamic sampling sparingly. Disadvantage number 5. Can mask underlying problems. Here's something people don't talk about enough. Dynamic sampling can become a crutch. If your statistics gathering is broken, dynamic sampling lets you ignore it. But you should fix your statistics strategy, not just band-aid it with dynamic sampling. Best practices. So when should you use dynamic sampling? Here's my guidance. Use dynamic sampling. 4.1 Data warehouse environments, perfect fit. Queries run less frequently and accuracy matters more than parse time. 2. ETL staging tables. These change constantly. Dynamic sampling is ideal here. 3. After bulk loads, just finished loading 5 million rows? Enable dynamic sampling for queries against that table. 4. Ad hoc reporting. Business analysts running exploratory queries benefit hugely. 5. Tables with data skew. When 95% of your data has one value, dynamic sampling helps the optimizer see this. Don't use dynamic sampling. 4.1 High-frequency OLTP queries that parse overhead will kill you. 2. Well-maintained statistics. If your stats are fresh and accurate, you don't need it. 3. Stable, slowly changing. Data lookup tables, reference data. Just gather stats properly. Level guidelines. Let me break down the sampling levels for you, because choosing the right level is crucial. Think of dynamic sampling levels like a dial that goes from 0 to 11. Yes, like Spinal Tap. But seriously, here's how to think about it. At the conservative end, we have levels 2 and 3, very light sampling. Alter session set optimizer _ dynamic _ sampling equal to 2. Level 2 does very light sampling. Oracle samples just a tiny portion of your table. You get minimal overhead, maybe 50-100 milliseconds added to your parse time, but the accuracy improvement is also minimal. This is good for when you have mostly accurate statistics but want just a little extra help. In the middle, and this is where I recommend most of you start, we have the balanced levels 4 and 6, moderate sampling, alter session, set optimizer _ dynamic _ sampling equal to 4, more aggressive sampling, alter session, set optimizer _ dynamic _ sampling equal to 6. Level 4 gives you moderate sampling. Oracle samples a reasonable chunk of your data, enough to get a good picture of what's really there. You're looking at maybe 100-300 milliseconds of parse overhead, but you get significantly better cardinality estimates. Level 6 is more aggressive. This is my personal sweet spot for data warehouse environments. Oracle samples more data, takes a bit longer, maybe 200-500 milliseconds, but you get really accurate estimates. For most scenarios, this is the Goldilocks zone. Not too light, not too heavy, just right. Then we have the aggressive end, levels 10 and 11, very aggressive. Alter session set optimizer _ dynamic _ sampling equal to 10, maximum sampling. Alter session set optimizer _ dynamic _ sampling equal to 11. Level 10 is very aggressive. Oracle is going to sample a large portion of your table. You might add a full second or more to your parse time. Only use this when you have a specific problem query that's absolutely critical, and you need the most accurate estimates possible. Level 11 is maximum sampling. Oracle samples almost the entire table. I'm talking multiple seconds of parse overhead. This is your nuclear option. I've only used level 11 a handful of times in my career, and only for queries where we were willing to wait 5 seconds at parse time to save 2 hours at execution time. Here's my recommendation. Start with level 4 or 6. Seriously, that's where you want to be for 90% of use cases. Test it, measure the parse time impact, see if your execution plans improve. Only go to 10 or 11 if you have a specific problem query, and I mean a specific one, where you've tried level 6 and the estimates still aren't good enough. Don't just crank it to 11 because more is better. It's not. You're trading parse time for accuracy, and at level 11, you're paying a heavy price. Monitoring. Now, how do you monitor if dynamic sampling is actually working? Here's the SQL I use. Check execution plans for dynamic sampling activity. Select SQL ID, child number, operation, object name, cardinality, cost from $SQL _ plan, where SQL ID equal to ampersand your SQL ID and object name, your table. Order by ID. Okay, let me walk you through what we're seeing here. This is the execution plan stored in the shared pool for our query. Look at the SQL ID. That's 8K3V5N2RNB4G. This is the unique identifier for our query. The child number is 0, which means this is the first version of this cursor. Now check out the operations. We're seeing index range scan on orders date IDX, then table access by index rowed on the orders table. That's exactly what we want. It's using the index. But here's the key thing. Look at the cardinality. It's showing 2,400 rows. If dynamic sampling worked, this number should be accurate. We need to verify this is actually from dynamic sampling and not just lucky old statistics. That's where this next query comes in. Look for notes about dynamic sampling in the plan. Select star from table dbms_xplan.display. Underscore cursor, 8KQV5M4G, null, advanced. Now we're talking. This is the smoking gun. Look at that note section at the bottom. This is gold. Dynamic statistics used, dynamic sampling, level boss 6. Bingo. It's confirming that dynamic sampling was used at level 6. This isn't using old statistics. It sampled the table during optimization. Dynamic sampling performed, sampled 2048 rows from table orders. It tells you exactly how many rows it sampled. In this case, 2,048 rows. Oracle took a sample right then and there to understand the current data distribution. Statistics gathered by sampling were used to generate this plan. This confirms that the execution plan you're seeing, that beautiful index range scan, was generated based on the dynamic sampling, not on stale statistics from weeks ago. And check out that last line. This cursor has been marked for automatic re-optimization. Oracle is saying, I'm going to keep an eye on this query. If the actual execution differs significantly from my estimates, I'll re-optimize it. This is how you verify dynamic sampling is working. If you don't see these notes, if it just says dynamic statistics used none or doesn't mention dynamic sampling at all, then it's not happening. You might need to increase your sampling level or check if there's something preventing it from sampling. So always check the execution plan notes. Don't just assume dynamic sampling is working, verify it. Also monitor your parse times. Select SQL ID, executions, parse out calls, elapsed R time 1,000. Nullif executions 0 as AVG elapsed sex CPU time 1,000. Nullif executions 0 as AVG CPU sex from $SQL, where SQL text like percentage your table percentage, order by last active time, desk. All right, this query is showing us the performance characteristics of queries hitting our table. Let me walk you through what we're looking at here, because this tells us a really important story about parse time overhead. Look at the first query, SQL ID 8KQ3V5M4G. This one has been executed 45 times and it has 45 parse calls. Notice something? Executions equals parse calls. That means every single time this query runs, it's doing a hard parse or a soft parse that requires optimization. And look at the average elapsed time, 6.2 seconds. The average CPU time is 5.9 seconds. Now, if dynamic sampling is enabled at a high level, a chunk of that 6.2 seconds could be parse time. Is that acceptable? Well, if the alternative is a 17-minute execution with bad statistics, absolutely. Now compare that to the second query, SQL ID 3HN7DWM9KP2XF. This one has been executed 128 times, but only 12 parse calls. That's cursor sharing in action. The query gets parsed once, cached, and reused. Average elapsed time? Just 0.156 seconds. That's 156 milliseconds. Average CPU? 98 milliseconds. This query is flying because it's not constantly reparsing. Look at the third one, SQL ID 7Me2QX8VNR5TK, executed 89 times, 89 parse calls. Again, parsing every time. But check out the average elapsed time, 15.7 seconds. And CPU time is 14.2 seconds. This is a red flag. If you just enabled dynamic sampling and suddenly this query went from 2 seconds to 15 seconds, you might have set your sampling level too high. This could be a query that's suffering from excessive parse overhead. Here's query 5, SQL ID 9XR4JN2VKT8QM. This is interesting. 234 executions but only 8 parse calls. Excellent cursor sharing. And look at the timing. 89 milliseconds average elapsed, 67 milliseconds CPU. This query is getting parsed occasionally, probably when the cursor ages out or statistics change, but mostly it's reusing the cached execution plan. This is what you want to see. Here's what you're looking for in this output. First, compare queries before and after enabling dynamic sampling. If your average elapsed time jumps from 0.5 seconds to 2 seconds, and most of that is parse time, you might need to dial back your sampling level. Second, look at the ratio of parse calls to executions. If they're equal or close, that query is parsing every time. Dynamic sampling adds overhead to every parse. If parse calls are much lower than executions, dynamic sampling overhead is amortized across many executions, so the impact is minimal. Third, compare AVG elapsed secs to AVG CPU secs. If elapsed time is much higher than CPU time, you might have wait events, maybe I/O, maybe locks. But if they're close together and both are high after enabling dynamic sampling, that's likely parse overhead. My rule of thumb: if enabling dynamic sampling adds more than 500 milliseconds to your parse time, but saves you more than 10 seconds in execution time, that's a great trade-off. But if it adds 2 seconds to parse time and only saves you 3 seconds in execution, you might want to reconsider or lower your sampling level. If you see parse time skyrocketing, you might need to dial back your sampling level. That's why I always say, start with level 4 or 6, measure the impact, and adjust. Don't just set it and forget it. Here's my honest advice. Dynamic sampling is powerful, but it's often a band-aid. The best long-term fix? Keep statistics fresh. Gather fresh statistics properly. Execute dbms_stats.gather_table_stats, owner name equal to your schema, table name equal to orders, estimate_% equal to dbms_stats, .auto_sample_size, method_opt equal to for all columns size auto, degree equal to 4, cascade equal to true. Enable automatic statistics gathering. Begin dbms_auto_task_admin .enable client_name equal to auto-optimizer stats collection, operation equal to null, window_name equal to null. End. Schedule statistics for volatile tables. Begin dbms_scheduler. .create_job_name equal to gather_staging_stats, job_type equal to PLSQL_block, job_action equal to begin dbms_stats, .gather_table_stats, schema, staging_table. End. Start_date equal to systimestamp, repeat_interval equal to frequency equal to hourly, interval equal to 4, enabled equal to true. End. Use dynamic sampling as a tactical solution while you fix your statistics strategy. So there you have it, dynamic sampling in Oracle. A powerful hack that can dramatically improve query performance, but with trade-offs you need to understand. Quick recap. Advantages. Accurate plans for current data. Great for volatile tables. Immediate performance gains. Handles data skew. Perfect for ad hoc queries. Disadvantages. Increased parse time. Cursor sharing issues. CPU overhead. Not ideal for OLTP. Can mask underlying problems. My recommendation: use dynamic sampling as a tactical solution for data warehouses, ETL processes, and reporting environments. But invest in proper statistics management as your long-term strategy. Start with level 4 to 6, monitor the impact, and adjust accordingly. If this video helped you, please hit that like button and subscribe for more Oracle performance tips. Drop a comment below and tell me, have you used dynamic sampling? What results did you see? And if you want the complete SQL script from this video, I've put the link in the description below. Thanks for watching, and I'll see you in the next video where we'll tackle another Oracle Performance Challenge.